Welcome to the second part of the state machines tutorial. In previous video we ended up creating the state the the mechanism state behaviors for the forward and backward state. We will not be implementing these scripts right away. Instead we'll continue with the view. So where is it? Moving disk view, here we go. And yeah, the last method we wrote was this onStateChanged, and which sets the animator in the correct state. And now we'll need a couple of functions here. Public void go forward. This is a simple function that does moving disk transition to state forward. And also, before we do this, we'll set yeah, I forgot, I remember now that we need another bool, private bool here, that tracks if we are going forward or backwards. So private bool going forward. This will be used later to know if we're going to start going forward or backwards after we have stopped it by stepping on the pressure plate. So before transitioning to going forward, we'll do going forward equals to true, and we'll copy paste, go forward, and also we need to stop. So go backward, going forward in this case naturally equals to false, and we transition to state backward. And here we don't say anything about the going forward boolean. Sorry, it should be stop method, and transition to stop. And then we need the last method for this type of functionalities is the continue method. Continue. And in this function we'll be looking at the going forward boolean. So if going forward, then we'll do transition to forward. No, sorry, we'll do go forward, of course, and otherwise we'll go backward. There we go. And that's it for those methods. And let's see, yeah, when we have initialized the action model, we'll simply say go forward as a starting point. And then we need a couple of state machine functions. Now you could write the code directly in the mechanism scripts, but I like to keep the code clean and as possible in the mechanism script, so I'll write state machine functions here that I will call from the mechanism script. If it sounds confusing, then it will probably be more clear afterwards. So here we go. Public void on state enter going, let's just call it forward, on state enter forward, and we'll do a lot of copy paste again. We need 3 for each state, for update, for enter, update and exit. And this represent the mechanism functions. So on state update forward, on state exit forward, on state enter backward, on state update backward, on state exit backward. And again, we don't need any methods for the non-state, which does basically nothing. And now we come to a bit more advanced code, so bear with me. We will be using the timer components here for an interval functionality that counts down a timer until the moving disk should turn and go backwards. So we'll do. Yes, the first time we enter this method, then the timer component will be null. So we need to check for that. So if the forward countdown timer equals to null, we need to do something, and otherwise we need to do something else if we already have the countdown timer declared. So here we'll need to create it. Forward countdown timer equals to mono extensions, component extensions within mono extensions namespace, component extensions dot add component. We need to add a new timer to this game object. So we create a persistent timer persistent game object. That's what we declared. So, and we create it on this game object. Then we need to say what kind of function should run each interval. So we say forward countdown timer dot timer method. Here we declare an anonymous function that we should run each time the interval happen. And last we do forward countdown timer dot setup interval infinite. We set up an infinite interval for this timer. So let's do an interval of 0.01 seconds. So this method here will run each 0.01 second. Here naturally we need to we will be using the forward countdown float to count down each interval. So first thing we need to do is we need to reduce this each interval, and if we reached 0 or below, if forward countdown equals to 0 or below 0, shouldn't be below, but never mind, then the timer has run its course, and we need to reset it and start going backwards instead. So forward countdown equals to 0, 20, not 0, 20. This means that if it's set to 20 from the start, then and the interval runs every 0.1 second, then it will run totally for 2 seconds. And after we have reset the timer, we go backwards. And that's it for declaring the timer component. And the next time we enter the forward function, then we already have the timer. So all we need to do then is forward countdown timer, start interval again. So if everything happens without if the timer runs out without being stopped, it will run this method 20 times and then go to backwards, and the backwards should do the same thing, and it jumps back here and starts the interval when the timer is when forward countdown is equals to 20 again, and it starts over. And then we need to move the actual disk within each update. So transform, translate, a simple translate. We can do vector 3 forward, or let's do transform forward instead. And we can do like time delta time times 5 or something. Should be good. And that's everything we need to do in the update function. And if an exit happens before the timer runs its course, then we do. If we do have a forward countdown timer, which we should, but we need to check for it anyway. If the forward countdown timer is not equals to null, then we simply stop it for the time being. Stop interval. So maybe you see where I'm going at here. So if the timer is run, for example, 10 times, the forward countdown is at 10, and suddenly it stops. It exits this mechanism. The mechanism enters another state and calls this exit function. This check if the forward countdown timer is not null, which it shouldn't be here. It stops the interval, and whenever it goes back to this enter function, we do not have a null forward countdown timer, so we go to this else instead, and we start the interval, and the forward countdown is still at 10. So it continues where it left off, which is exactly what we want. So now we have implemented it. We're going to copy paste it and just change the names. This is the backwards countdown timer. And here and here. And this is the backwards countdown. And here we go forward instead. There we go. And we can copy this also for the update, transfer update, and we do simply negative forward to be going backwards. And for the exit, we do another copy paste, and we change it to the backwards countdown timer. And let me just indent this code. No, didn't happen. There we go. Yeah, I think we're good. So let's try this out and see if anything happens. No, we have compilers, so let's see what's going on. That was weird. Okay, so I'm back. I don't even know what happened, but never mind. We're back and the code is compiling again. So hopefully it's compiling again. Yeah. So we can try it out now. See what happens when we hit play. Nothing happens. Of course, nothing happens. We haven't attached the scripts to the object. Nothing should happen then. So we need to add the moving disk view, and now we should be seeing something at least. Oh, we have an error instead. Object reference not set to an instance of an object. Oh, sorry, we haven't declared. Well, we have declared the animator, but we haven't set it. So public override awake. We do base dot awake, and we do animator equals to get component animator. And there should be a void there also. And hopefully we'll get some sort of result now. No, missing component exception. There is no animator attached. Oh, Jesus Christ, I've forgotten to attach the animator. I'm rushing this, but apparently it takes more time instead. So animator, and we set up the moving disk controller there. Let's try it now. Okay, we don't have any error, but it's not moving. It's going forward, and I know what's not. I know what's wrong. We haven't implemented the state machine behavior script, of course. My only excuse is that it's Friday. So let's do this right now. This should be fast. We do on state enter, we fetch the view, the the moving disk view. So, and we need a variable. We can do a private moving disk view, moving disk view. No, it's still not correct. Moving disk view, and we need to be using AGS core. I think it's called like examples. Oh my god, examples dot game view examples, and oh, what's wrong now? Moving disk view, let's see, it's in system examples. Okay, examples, system example. There we go. Finally, moving disk view equals to get animator get component moving disk view, and we do moving disk view dot on state enter forward. Unless we call a method, then nothing will happen, of course. So we do moving disk view dot on state update forward. And finally, for the forward script, we do moving disk view dot on state enter exit state exit forward. And guess what I'm going to do now? I'm going to copy this and probably fail in some way. I also need the namespace. Using AGS core examples system example and on state enter backward on state update backward on state exit backward. There we go. Woohoo! We have a moving disk finally. But we don't have the functionality to... Oh, it's not working. The moving disk is not turning around. So... Well, it did turn backwards, but it did not turn forward. Okay, so it was, of course, a copy-paste error, and we need to do backwards countdown minus, of course. So hopefully it will at least go forward and backwards now. Yeah, and we can do like this, so we can see that the state mechanism states are changing here, and it's driving the moving disk with the update function. And now let's do the pressure plate additional functionality to stop the moving disk from moving, and when we step off the pressure plate it should continue where it stopped. So for this we'll do I'm going to copy paste again, and of course I'm going to fail again, but let's try. Example ViewScripts. We have this pressure plate color script, and I'm going to duplicate that one, and I'm going to call it moving disk stopper, no controller, no moving disk stopper. It's Friday, sorry. Moving disk stopper. A very good name. Moving disk stopper. And what do we do here? We don't need a light, we don't need a renderer, we don't need an awake function at all. We don't need this, but the rest of it is already implemented for us. So all we need to do is set up a reference to the moving disk. So public moving disk view, moving disk view, and here we do if the pressure plate is pressured, then we need to stop the moving disc. If the moving disc if the pressure plate is pressured, we do moving disc view dot stop. Otherwise we'll do if is pressured dot value, else we do moving disc view dot continue, and we add this script to the pressure plate when it's compiled. Moving disc stopper, and where is it? There it is, and the reference to the moving disc there, and we should be all set. If I step on this, the moving disc stops. No, it didn't stop. Oh yes, it did stop, sorry. It's the camera that's moving, so it looked like the moving disc was moving sideways, which would be really weird. But it's actually working, yes. We can stop it, and whenever we step on it, it stops, and whenever we step off, it continues where it stopped. So that's it for this tutorial.